How are you, everybody who is watching this fantastic video? I'm very happy to have you. I would like to take this opportunity, first of all, to welcome into this fantastic program. Whether you are international or a national student, whether you're an international or national parent, or a teacher, or a guardian, or actually that is sponsor who is sponsoring students, you're warmly welcome, or anybody else who just made possible, you're an engineer or you are a scientist, you are warmly welcome into this fantastic moment. And I would like to just spend a few minutes to give you a brief introductions concerning about what are we doing and what and where are you, so that you may not, because we have always new viewers or new people or new students or new viewers who are watching this program for the first time. So I'd like just to give them just a little introduction. Firstly, I would like to welcome you into one of our online schools that's called TANZANIA Online Advanced Secondary School in square bracket Olenjolai. Again, I would like to take this opportunity to welcome you into one of our official YouTube channel that's called that's called TANZANIA Online A-Level Secondary School in square bracket Olenjolai. I know that you have been welcomed. Thank you very much for getting in or for being a part of watching this program. I would like just to share with you some of the relevant information for you to keep in your mind whenever that we are going or we are moving together. The first thing which I want just to let you to, I want you to be aware. I know that you have so many questions. You can be asking yourself so many questions. What is the visions of TANZANIA Online Advanced Secondary School? Or you can ask yourself so many questions that, what are we doing? What problems are we solving? Are we solving your problem, or are we solving somebody's problem? Are we solving a national problems? Are we solving critical problems? Are we solving simple problems? So what kind of the problems are we solving? So when I give you the vision, then you'll get the understanding that what kind of the problems that we are solving. However, that you have to watch also session 00, the general introductions of advanced physics from 5 through from 6, which you can access in our YouTube channel that's called TANZANIA Online A-Level Secondary School. So we have an assignment. Our vision, or the visions of TANZANIA Online Advanced Secondary School in square bracket OLENJOLAIM is to teach and train some of the students who will be ready to extracting knowledge, understanding, and wisdom from the classroom instructions in advanced level, and combined with the knowledge, understanding, and wisdom that will teach them to extract it from the Word of God written in the Holy Bible in order to solve real life problems. So our main objective in TANZANIA Online Advanced Secondary School in square bracket OLENJOLAIM is to teach our students on how they can take the classroom instructions in order to solve real life problems, because that is the objective of study. However, that will be focusing on solving real life problems, which is actually means prosperity or successful in life, but also we won't eliminate the part of formal learning of advanced education. So if that's the case, that's why that we'll be focusing. It's one of our specific objectives to have all our students to understand and love advanced physics, advanced chemistry, basic applied mathematics, and advanced mathematics. So if you've been given up or you've been experiencing so many challenges on learning advanced physics, you are either students of who wish to study, or who is studying PCM or PCB or PMC or PGM, or you are an ordinary student and you encounter some of the modules or courses that involve physics, really are tough for you to go through them. Possibly have given up, I would like just to tell you that please, before you give up and you quit from advanced physics or you quit from actual higher level physics, I would like to ask you that to try the methods and to try our learning system, or to try our teaching system in order for you to prosper, right? So how are you going to try? Be a part of TANZANIA Online Advanced Secondary School. So I would like just to welcome you once again in this interesting part, which is registration to ASO. To ASO is abbreviations of 40 TANZANIA Online Advanced Secondary School in square bracket Olenjolai. So whenever you go in a physical school, on the first day, you have to register yourself to be a part or to be a student of that school. So the first day, if you don't have an email, please create or open new email. Only one is enough. And these new emails, it can be either Yahoo Mail, or it can be a Gmail, or you can have both of them. For example, myself, I have a Yahoo email and I have a Gmail. If you have an email. Then you can skip the first step. You go to the second step. The second step, we ask you to sign in YouTube, and you cannot sign in without an email. That's why that the second step will not be possible for you if you don't do the first step. Okay, sign in YouTube by using what? By using your email. Sign in YouTube by using your email. That's the first process. Then the third step, we say that when you are in YouTube right now, you have said that you are in YouTube by using your smart TV, by using just the computer, by using a laptop or smartphone or an iPhone. Okay? So search what? Search TOASO. TOASO. Don't write TOASO, but just write Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM. So you have to search what? TOASO, and then you find you are there. So you'll see the round buttons with the national flag. I'm a Tanzanian and I'm doing these programs. At the name indicating of our advanced school, we are focused and we are using the syllabus of United Republic of Tanzania. However, that advanced physics is universal, so every student across the world has to learn about advanced physics if you want to pursue science program or to pursue medical programs, to pursue farmers programs, or to pursue engineering programs. You have to study advanced physics. So even international students, you can benefit on this program. The issue is just to have your syllabus in your hand in order for you to go through steps or to go through our contents. So when you search the TOASO, then look at the bottom of your right hand side, and then we ask you what? To click the button of what? The button of subscribe. The button of subscribe. So the button of subscribe, it means that we ask you to click it. So when you click it, then the text will be changed into subscribe, and even the color of the buttons will change. So then we have the icon of the bell. So it will appear after you click the buttons of subscribe. Then you click this icon once, and then you see 3 options. Choose the option of all. Then we can go to the 5th step. I believe now when you do the 4th step, you're already an active student in Tanzania Online Advanced Secondary School. Why should you subscribe? That's the very good news. We have a vision to record more than 500 videos of the active learning in 8 subjects, in 4, is it 4? In 6 subjects, no, is it in 8 subjects of advanced education. So at this moment we'll be doing that, but later on we'll be adding some more subjects as well as we can. So whenever we upload any new video, it means whenever we add any new lecture or any new video, then we'll be, and you are online, or you will be online next after the uploading the video. You will be given the official notification from the YouTube community that Olenjolai has added the next session or has added a new video in his or her channel. So you have to watch. So again, we say that in the 5th step, we believe in God and we trust in God that you will enjoy what we are teaching, and you will enjoy our teaching. You will enjoy advanced physics. So I know after you enjoy, whenever you get any good things, the next step are the mankind's you used to share with your classmates, with your friends, with other students across the country, because these programs is accessible in any region at any time of Tanzania. So all 31 regions can access these contents at any time, and also they can enjoy as well as they can, because right now the light is lightening in the entire country of Tanzania, but these contents are also relevant for the African continent, for European continents, for America, and even Asia continent and Australia continent. So the next step, you can click an icon which has been written share, in order for you to share the link of this video with your friends through WhatsApp, through social media WhatsApp, through Instagram, through Twitter, through Facebook, through Telegram, through TikTok, etc., through your email. Also, you can share your colleagues. And he asks them also to subscribe as well as they can. Okay, so thank you for registering. You may do this. I ask you to do this process right now before you forget, for your own advantage. So we are in departments of advanced physics. The subject of the day is called advanced physics for pre-form 5 or for the form 5 students, or in some of the countries we call it class 13. For example, in India, this is class 11. So, and these programs of advanced physics is being studied in Tanzania for the students pursuing the following combination: PCM, PCB, PMC, PGM, and the ordinary diploma. PMC means advanced physics, advanced chemistry, and also computer science. Okay, so quick review of session 13. So, okay, so we are in the main chapter. Before this quick review, ladies and gentlemen, I forgot something. We have the main topic. So we have the main chapter or the main topic. The main chapter, so the main topic for this is what is called the electrostatic. So, where are we going to start? I will give you some announcement later. Where should we start? Where can we start? Okay, so the point that we have to start, let us start with quick review. I would like just to give you a quick review, and then we go into session 14, which is solving conceptual questions of electric field, and will be the question. Will be to do the questions. I will do two questions. I will do two questions of advanced certificate secondary education examination paper 2, because electrostatic, the questions of electrostatic appear in physics in advanced certificate secondary education examinations of paper 2, advanced physics paper 2. That's the point, or that's the paper where we find the questions in Tanzania for the Tanzanians. Okay, so the quick review of session 14, session, let's say the quick review of session 10 to session 13. So you have to remember that when you've been discussing about electric field, that suppose you have a point charge here, and then you want to look the electric field that experienced by the point at this point. So suppose that this is quantity of charge Q, and then suppose that this is point P. And here we have a distance between the center of this charge and this point, which we call the R. So electric field strength for this case is equal to constant K, then times quantity of charge of voltage over square of the distance between the point and the point charge Q. That's what we have to remember. So this is the process. But remember, electric field strength is a vector quantity. So in some of the books or later, when you go for undergraduate, and you'll be learning about electromagnetism or different cases of electrostatic, then you'll find that this is expressed as a vector quantity, just like this one. But this here we used to treat it as a scalar quantity. So that's very important. But again, I have to remind you that we'll be using the concepts of resultant. From the concepts of resultant force, here we are going to have resultant electric field. So this one is equal to what? Is equal to square root of what? Of summation of electric field along x-axis square plus square root of summation of electric field along the y-axis square. So that's the resultant electric field. But you can find also the resultant electric field along x-axis. So when you find resultant electric field along the x-axis, depend. So you can have maybe EX1 plus or minus, depends on the direction of EX2. How do we find the resultant electric field along y-axis? We may take E of y1 plus or minus E of 40 of y2. So all of these are the process that you have to do. So before we go into the contents or into what I've prepared today, let us start from example. What's 27? I'm not mistaken. So let me check example 27 or what? Because we have to deal with solving conceptual problems, let us do correction of homework 13 that I left in session 13. So it was example 27. After we do correction, this is the example 27, and it's concept. So the question was said that, the square ABCD having each side 4 centimeter, find electric field strength at what? At E. So assume the medium. Assume the medium is air. Assume the medium is air. Okay, so that's the questions, and then so be given static square of 4 centimeter each side. So a square of ABCD having each side 4 centimeter, find the electric field strength at D. It's okay. So let us move from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then this is a square which is being given. And here we have, first of all, each side is 4 centimeter. This is 4 centimeter. And this is 4 centimeter. And this is 4 centimeter. Okay? Then we have what? We have A, B, we have A, B, C, D. We have A, B, C, D. Then positive 8, exponent negative 9 Coulomb. So positive 8, exponent negative 9 Coulomb. And then there we have what? Positive 32, exponent negative 9 Coulomb. Exponent negative 9 Coulomb. And this one is positive 24, exponent negative 9 Coulomb. Okay? 9 Coulomb. So 4 centimeter, 4 centimeter. That's the question. And this is, I don't remember, but I think I labeled as, okay, so even if that we don't label. So please, before we solve this question, I ask you to copy those steps of registering into the TOEFL. So I left these questions in session 14, which are titled as solving conceptual problems of electric field. Okay, so let me solve it, and then I will give you the same typical question for the homework. So solution. So a square ABCD having each side 4 centimeter. Find electric field strength at D. Assume the medium is air. So we'll be following steps. Okay? The first step, you know, in advanced level, we are not interested about data collect, about data giving. We just go straight forward and deal with the problem. So the first step, we have to say that, okay, fine. So we have that, okay, so you can start maybe even data given, if you're interested to. But data given, I think that will be wasting time, because this data are already given, so you have to deal with it. So we say that the first step, let the pointy charge of 1 exponent negative what? Negative 9 coulomb, but this is positive, to be located, that is test charge, at what? At D. Case we need. However, that in electric field we don't need a point charge. If it is electric force, then we need that point charge and use in computation. Please pause the video and copy these procedures. Possibly that for you are familiar, but these procedures can help your friends to join into this program. And I believe that you have copied and you have subscribed, and whenever that you forget the procedures, we can review. So that's the first step. Then the second step, we say that resolve the electric fields along square A, B, C, D. Right? So right now, let me do that, just the sketch. So this is a sketch. Maybe you find that the distance, distance is a little bit different. 4 centimeter, and this is 4 centimeter, and this is 4 centimeter. So for here we have positive what? 8 exponent negative what? 9, no? And also there we have point D, and this is point A, and then this is point B, and this is point C. So we've been asked to find the electric field strengths at this point D. So electric field strengths at point D, due to point charge at point A, will be directed in this direction. So this will be what? Electric field strengths are experienced by D due to N. Right? And then here we are. So electric field strengths at D due to what? Due to B, this will be what? Will be experienced in this way, that this is electric field strengths at D due to point charge B. So this one, because here we have positive charge, and this is positive, so it will be repelled. So here also we have what? A positive charge of 32 exponent negative 9 coulomb. So positive, also the point charge, because remember that this one will let us 1 exponent negative 9 coulomb, but positive. Okay? So this charge also will be pushed away, so it will be repelled. Then at point C we have positive what? The point charge of positive 24 exponent negative 9 coulomb. So this is positive and that is positive. Don't you have any negative? Let me check. Don't you have any negative? No, there's no any negative point charge. So even this one also will be repelled. So the point charge at D will be repelled. That's why we let the point charge to be 1 exponent negative 9 in order to know the direction of electric field strengths. So later on, because this one we can resolve, it means that we can prolong. And also here we can prolong like this one. And this one we can prolong because this is diagonal line. Okay? So, but we'll deal with it later. At this moment, let us keep on with what we can do as physicists. Okay? So ladies and gentlemen, the first step of solving this conceptual problem is a conceptual problem. And the good thing that later on in electric potential, there's one questions have been asked in advanced certificate secondary education examination, but of the same questions, you'll be given 4-point charge, but you have to find electric potential, which is the next topic, or the next subtopic of what electric field. Okay, so if that's the case, we say that we go for the steady state. Ladies and gentlemen, are you ready for the steady state? Please tell us in the comment sections whether you understand what we are teaching you or not. So we have to find what? So let us find electric field strength at 20D due to point charge at 20A, right? So to find this, we have to recall the general formula of electric fields. It means that EDA, this is equal to what? Is equal to constant times quantity of charge. Quantity of charge at which point? Quantity of charge at 20A of what? Over R squared. So the proportionality constant is 9 exponent 9 times quantity of charge at 20A, it's 8 exponent negative 9, right? Coulomb. Then what the distance? The distance between this point and this point is 4 exponent negative 2, but we have to square. So by using your scientific calculator that you can order, if you don't have, you can order it in TANZANIA online advanced library. Then this and this will cancel, so we have a numerator of 72 of what? Over 4 exponent negative 2 squared. So if you do your computation, you'll find 4.5 exponent 4. So the response is 4.5 exponent 4 Newton Coulomb. Okay? Then this is first step. First step, we say that what? Find what? Find electric field strength at what? Find electric field strength at D due to what? Due to C. Okay? Or let us start due to B and then due to C, because we'll come up for electric field strength at point D due to B, because we have to use Pythagoras theorem. So at this moment, I don't want to touch that concept yet. Okay, because I want to teach you from the simplest concept to the difficulty concept to the complex concept, and I simplify them. So electric field strength at point D due to point charge C. This will be using the same formula. So we have 9 exponent 9 times what? 32 exponent negative 9 divided by what? By the distance, which is 4 exponent negative 2 squared. So if you do this computation by using your scientific calculator, you'll get EDC as what? 1.35 exponent 5. 1.35 exponent 5 Newton per Coulomb. That's the SI unit of electric field strength or electric field intensity. Okay? Okay. So, if that's the case, we go on the fifth step. The fifth step, now we know the electric field strength experienced at D due to point charge C, and the electric field strength experienced at point D due to the point charge A at point A. So we don't know this. So to deal with this one, okay, we are going to use the same formula, but the issue is we have to find the resultant distance first. The resultant of this right angle triangle BCD, because this is a right angle triangle. Okay? So the fifth step, we say that find what? Find the distance sorting, find the distance BD by using what? By using the Pythagoras theorem. Pythagoras theorem of what? Of triangle what? BCD. Right. So I think you've copied the question and nothing new you still have, or even if you refer your notes that you copied in session 13, This is the series. We are going to have more than 20 sessions of electrostatic. This is just session 14. So we still have more than. I think that you will have more than almost 25 to 30 sessions of electrostatic, because I didn't teach about electric potential. I haven't taught you about potential energy, okay, electric potential. I haven't taught you about potential energy. I haven't taught you about capacitor, which is very interesting topic of electrostatic. And I like it, and I will teach you practically because I'm electronics and telecommunication engineer, and I used to enjoy the beauty of capacitor and the work of capacitor in every kinds of the design of electronics. If I want to store charge, or if I want maybe to remove the noises in a particular design, so capacitors really are doing great job, and you'll be surprised how they work. Okay, wonderful. So then to find that distance, we say that we have this right angle triangle. Okay? We have this right angle triangle, which is B, D, then what? C. So here we have what? 4 centimeter, and this is we don't know. Okay? And here we have 4 centimeter. Suppose that the figure is like that. So by Pythagoras theorem, we say that BD square is equal to BC square, and then this is equal to CD square. So BD square is equal to square root, or BD itself is equal to square root of what? Of BC square plus CD square. So the distance BD, which is this one, is equal to the square root of what? BC, it's 4 centimeter. We can find this centimeter. Later on, so we express is 4 square, and this one is 4 square. So what the response? So the response, this is equal to square root of 32 max centimeter. That's what you've been finding for. So we go for the 6th step. You can express in decimal, or you can leave the way it is. The 6th step, we say that because we know now the distance, find electric field distance experience at point D due to point charge B. So you have to remember that according to the formula that has been given by physicists, okay, that this is constant, or we have a constant, or electrostatic constant, over times quantity of charge over square of the distance between the point and the charge. Okay. So K, or electrostatic constant, is 9 exponent 9 times what? Q, but this is Q at what? Q at point B. Remember that this is Q at point what? Okay, so you have Q at point C. So Q at point B, it's what? It is positive 24, so we don't involve a sign, okay, either positive or negative sign in our computation. And then you have a distance, which is 32 exponent what? To negative 2 squared. So use your scientific calculator, and then you find EDB. If you use your scientific calculator, and if you don't have, in case you don't have a scientific calculator, which is being recommended by the Tanzania Institute of Education and Ministry of Education and Vocational Training, Ministry of Education, Science and Vocational Training. This is the scientific calculator. The good news, we have Tanzania online library, okay, Tanzania online advanced library, where we can order this scientific calculator with very minimum price, and we can ship in any 31 region. So whether that you're in Kigoma, we can send this scientific calculator to you once you buy it, and you pay what the transport cost. Again, we have some other books, some other reference books that we recommend our students to have when you are learning advanced physics. This is one. It's called the S-Chandis, or it's called the Principles of Physics. And this is class what? The authors are V.K. Hemeta and Rohit Mehta. This is for class 11 in India, but it's a very useful book for Form 5 advanced physics, because we learn mechanics, we learn also heat in this book, we learn wave and vibrations in this book, but electrostatic will be in the principle, S-Chandi principle of physics 2. This is physics 1. But I want just to show you sample. But you have also physics 2 in our library. You have to go into the descriptions of this video. But that's not enough. We like also to equip our students on how they have to think different on solving problems. And these are the classroom problems. Later on, we'll challenge you and we'll take you outside of the class. We are in the class right now, right? Later on, we'll take you outside of the class, so you have to stay tuned. And we are going to use extraordinary approach that has ever been existed in Tanzania, but it has been existed in the kingdoms of heaven. So this is Advanced Physics 1 review. It's paper 1, Advanced Certificate Secondary Education Examination Questions and Answers of 2003 through 2016. Again, we have this Advanced Physics 2 review, questions and problems for 2006 and 2004. For example, questions of electrostatic are questions number 5 or question number 6 in paper 2 of Advanced Certificate Secondary Education Examination or of Advanced Physics. In case of nectar questions, and even that the format for the pre-nectar and even format for the moco and promoco. So please, you can access a bunch of all of these books, it means that all of this entire package with a very minimum price compared with the price that you can buy in the local shops. So you can order this, just read the descriptions below, you will see the link of the price and even the shipping cost, so that you can order for you to go further as God will take you. So the electric field strength at 20D due to B is 9 exponent 4. So if you use your scientific calculator, 9 exponent 4 Newton per coulomb. You can prove, okay? So you can prove. This is very simple. So we have what? Square root of 32. So let us find the denominator first. And then multiply by 1 exponent negative 2. And then this one will square. And there we have what? 9 over the response. 9 over the response. And then multiply by what? By 24. What happened? Okay, so this is square root. It's not involving on what? It is involving also exponential part. So it is 32 exponent negative 2. Then find the square root. Then take 9 over the answer. Then multiply with 24. The response is, so it's 9. Do I interchange? Yeah, I made a mistake there. EDC. This is 4 exponent. I made a mistake somewhere. Let me cross check and even answer cross check. So we have 9 over the response. And then multiply by what? By negative by 32. So this is 1.8 coulomb. So I just in, because this is EDC, C it is 24, not 32, excuse me. 24 exponent negative 9. So for that case, you have 4 exponent negative 2, then we square, then we have 9 over the response, then we multiply with what? Multiply with 24. Answer is 1.35 exponent 5. Okay? So the answer is right, but the computations is wrong. So this also is wrong, because the point charge at point D is 32 exponent negative 9. Right? So if that's the case, we say that what? So we have what? We have 32 exponent negative 2. Then we find the square root of the denominator. And then we have what? 9 over the response. Then we multiply by 32. The 2 exponent negative 2, then find the square root, then 9 over the response, then multiply by 32. Okay, so let us redo it again. 32. Okay, I think we made a mistake since then. 16 by 32, negative 2, find the square root of 8, then we have 9, multiply by 32. The answer is different from what I found during my computation. Why? And I have 4, so negative 2, n square, we multiply by 2, we get this. So then we square this. Aha. So then we have 9 for the response times sorting to 2. Four exponent negative 2 square times 2 and under root, then square 9 over response times 32. Yeah. So I made a mistake once again here. The best way I have to express, because we are going to have these units, the best way, we say that this, you have to express this in meter. Whenever you find that you are using Pythagoras theorem, please express the quantities in their SI unit form. So if you do that, here we are going to have what? We're going to have a square root of what? So we are going to have 32 exponent negative 3. Square root of 32 exponent negative 3. 3.2 exponent negative 3. Or let me just find the response here. Okay, so there we have 4 exponent negative 2. Then we square it. Then we multiply by 2. We get here. So the response is square root of what? Square root of 3.2 exponent what? Exponent negative 3. So negative what? 3. So okay. So we have 4 exponent negative 2. Then this is square. Then multiply by 2. Then we find the under root. So simply this is 3.2 exponent negative 3. So if you find that, then 9. So simply it means 9 over 3.2 exponent negative 2, negative 3, and hence multiplied by what? 32. Okay, so the answer is 9 exponent 4 Newton per coulomb. Okay. So then we know the directions that. So let us go to the resolving. Okay? Resolving what? The forces. This is how physics is challenging. So to resolve the forces here, so we don't need these values. So this is 20D. So to resolve the forces, the vertical line can be prolonged like this. This horizontal line can be prolonged like this. And this diagonal line can be prolonged like this. So here, because this diagonal bisected this right angle into 90 degrees, so here we have 45 degrees. But here we can form also another right angle triangle. So to form another right angle triangle, we say that here we have electric field strengths along what in x-axis. Okay, and here we have electric field strengths, okay, due to what? So this is due to a 20D due to B along X. And here we have electric field strength dB along Y. So here we have an angle 40 and angle 45, right? So, because remember that this is actual, the field is like this. So we have field in horizontal component and field in vertical component. So the next step right now, we say that 7th step. So refer, suppose that this is figure 14.3. So this is figure 14.3. Okay? So refer figure 14.3. So we say that electric field strength, so we say that the cosine, for example, cosine of 45 degree is equal to adjacent, which is electric field strength according to D due to Bx of what? Of electric field strength at dB. So electric field strength at dBx, this is equal to electric field strength at dB cosine of what? Of 45 degrees. Okay? Then similarly, by using the trigonometrical concept, dBy is equal to electric field strength dB, then sine of what? Sine of 45 degree. Right? So this is the figure. So if you check right now, we have ADB along x-axis and we have ADN. And along y-axis we have also E. Along y-axis we have what? This is E, D, what? EDC. So along y-axis also we have E, D, C, no, EDB, EDBY. So EDBY, and then we have EDBX. Okay? So draw that figure correctly. I believe you finished to copy. So let me bring this space. Okay. So if that's the case, we go to the 8th step. Okay? The far figure, this one, find what? Far figure, that one, find this formula for that. So before the 8th step, we can say that you have E dB along x-axis will be equal to E dB, where the E dB is 9 exponent 4 Newton Coulomb cosine of 45. This is equation 1. Then we have what? E dB y is equal to 9 exponent 4 sine of 45 degree. This is question 2. Okay? So if that's the case, we go for the 8th step. 8th step, right? So the 8th step, we come here and we like to say that, so resultant force, not resultant force. Resultant electric field strength along what? Along x-axis. So this one will be summation of electric field strength along x, which is equal to electric field strength due to dB due to dBx, and then plus what? Okay, so but this one, we say that EDB dBx plus what? Plus electric field strength upon D due to M charge N. But remember, EDBx is that one. So we say that resultant electric field strength along x-axis is equal to what? Is equal to EDA. The EDA is equal to what? ED8 is 4.0. So EDB first is 9 exponent what? Exponent 4 cosine of 45 degree plus what? EDA, which is 4.5 exponent what? Exponent 4. 4.5 exponent 4. 4.5 exponent 4. So, resultant electric field strength along x-axis, this is equal to what? This is equal to 13.5 exponent now. So just use your scientific calculator to find the right response. It's 9 exponent what? 4. Then we have cosine of 45 degrees. So this one is 6.364 exponent what? Exponent 4 plus what? 4.5 exponent 4. Right? So resultant electric field along x-axis. So this will make what? So this will make 10.86. Okay, 864 exponent 4 Newton per coulomb. Isn't it? Wonderful. 10.864 exponent 4 Newton per coulomb. That is resultant electric field along x-axis or along x. The ninth step, ladies and gentlemen, let us find what? Let us find resultant electric field along y-axis. So to find resultant electric field along y-axis, then ladies and gentlemen, we have to deal with this process. We have to deal with this process. That we have to refer figure what? Figure along y. We have to refer figure 14.3. Do you enjoy the beauty of electrostatic? Do you enjoy the beauty of solving conceptual questions of electric field? Do you enjoy the beauty of advanced physics? Please tell me in the comment sections. I want to hear from you. I want to get a feedback. Tell your neighbor, let us give our beloved teacher Olenjolai feedback, that we understand the concept that he is teaching us. Please give me the feedback, because I used to be happy when I get the feedback that your problems have been solved. So then the electric field, the resultant electric field along y-axis. So you see that this means physics is not difficult. Electrostatic is not difficult topic. It depends on how you define it. So EDC and then plus what? Again, so you have plus EDBY. Electric field strength at D due to what? Due to point charge at B along y-axis. So then we remember that the resultant electric field strength along y is equal to EDC. EDC, what is EDC? EDC 1.35 exponent. 1.35 exponent what? It's 1.35 exponent 5 Newton per coulomb. Newton per coulomb. So we go for the 10th step. For the 10th step, we say that find resultant electric field strength. Find the resultant electric field strength at what? At D for the given square. So to find the resultant, so you say that resultant electric field strength is equal to the square root resultant electric field strength along x, and then if you square plus what? Resultant electric field strength along y-axis. Okay? So electric field strength, this is resultant charge or resultant field strength. Then she said that the resultant electric field strength along x-axis, it is what? It is 10 0.864 exponent 4. Then plus what? Let fill the strings along y. It's 1.35 exponent what? Exponent 5 square. So resultant electric field strength, this is equal to what? (10.864 exponent 24 square plus what? 1.35 exponent 5 square. Then under root of the response, it is what? 170. It means 1.73. Wonderful. 1. Excuse me, I made a mistake here. So this is EDC, and then plus what? Plus EDBY. It's 9 exponent what? 4 sine of what? Of 45 degrees. So the response, we have 9 exponent 4 times what is sine times sine of 45. The answer is 6.36. Then plus what? Plus 1.35 exponent 5. Answer is 1.98. So the answer here is what? 1.986 exponent what? Exponent 5 Newton per Coulomb. So 1.986 exponent what? 5. So let us take 10.864 exponent 4 square plus what? 1.986 exponent 5 square. The answer is 5.124. Choose me. There we have 10.864 exponent 4 square. Then plus 1.986 exponent 5 square. Then find the square root. It's what? 2.26 exponent 5 Newton per Coulomb. So this is 2.264 exponent what? Exponent 3 Newton per Coulomb. So that's the resultant electric field strength at D. So we go to the 11th step. The 11th step, because there we have, so if this is a resultant force of EDA, EDB, and the EDC, it will make a certain angle with x-axis. So 11th step, we say that find. So remember that we said that electric field is vector quantity. Then let us find what? So let us find the angle. The angle or directions of what? Of resultant electric field. Resultant electric field. Resultant electric field. Okay, so if that's the case, we count that. How do we find M? Wonderful. So we have to recall, we have to know the angle of what? Of electric field is found similarly with how we find angle of electrostatic force. How? So the angle of electric field, which is equal to theta, this will be equal to tan inverse of what? Resultant electric field along y over resultant electric field along x, like this one. So the angle theta is equal to what? Is equal to tan inverse of what? Tan inverse of what? Of resultant or summation of electric field along y-axis over summation of electric field along x-axis. Okay? So theta, this is equal to tan inverse of what? Of resultant electric field along y-axis. Resultant electric field along y-axis, it's 1.986 exponent 5 Newton per Coulomb. And resultant electric field along x-axis, it's 10, it's let's say 0.0864 exponent 5 Newton per Coulomb. So Newton per Coulomb and Newton per Coulomb cancel. So you have to use your scientific calculator to find the tan inverse of this. So just take 1.986 divided by 1.0 because exponent 5 and exponent 5 cancel. So divide by 1.0864. So we say shifting tan inverse of the answer. So the angle is 61.32 degrees. So therefore, I will say resultant electric field, therefore, you have to refer the sentence of the question that you calculate the electric field at the, so the question calculate electric field strength at D. So therefore, electric field strength at D is, what is the resultant? It's 2.264 exponent 3 Newton per Coulomb in direction of what? In direction of, if you join me right now, you're warmly welcome. I'm teaching you how you can solve conceptual or complex questions in electric field. The main topic is electrostatic. These are the questions which have been asked in terminal exams, in annual exam, especially in annual exams. I've been asked in annual exams, in pre-mock exam, in direction of 14, in directions of 61.32 degrees. So this is the final response, and that's what I asked you to do. Please cross-check your solution. I guess, I'm not sure, I guess that there are some points that you've made mistakes. Don't worry, and don't be discouraged because you did mistake. Even myself, what I'm teaching you is outcome of 80% of the 80% of what I'm teaching you is the outcomes of the mistake I have done it several times when I was studying advanced education. So don't be discouraged because of the mistake that you are doing or the mistake you have learned. It's better to learn through mistakes rather than anything else. So that is all about example 27. Ladies and gentlemen, I would like also allow me to present you example 28, and I'll teach example 29 And then so leave the homework, which example 30. So we have we solved these 30 questions in electrostatic. So example 28. And this example 28 will ask you to refer this book, Physics, review Physics, Advanced Physics 2 review, refer Advanced Physics, Advanced Physics 2 review, or Advanced Certificate Secondary Education Examination of which year? 2018, if I'm not mistaken. 2018 or 2017. I want just to give you the overview concept. Now we are looking, or I have to teach you how you can solve nectar questions or past paper questions or final exams questions, right? So the question for electrostatic is the one of the question in section B of Advanced Certificate in Secondary Education Examination, paper 2. And in most cases, it should be question number 5 or question number 6. It depends to the year. So this Advanced Certificate Secondary Education, you have to refer of 2000. So Advanced Certificates, Advanced Certificate Secondary Education 2, paper 2, and then we said that 2018, and we are referring question 6. Question 6 will be asking you about some other concept that I didn't teach you, but so there are 4 subsections of question 6. Part A, I haven't taught you, briefly explain the effects of the electric material, I haven't taught you. Part B, how the electrolytic capacitor made, I haven't taught you. Part C, I have taught you that 2-point charges of equal masses M and charge, that ones I've taught you. Part D, it's the one that I'm going to solve, ladies and gentlemen. So it's question number 6D. Okay, question number 6D. So the question, the question states that 2-point charge, 2-point charges, QA is equal to positive 3 microcoulomb, and QB this is equal to what? Is equal to negative 3 is equal to negative 3 microcoulomb. Okay, negative 3 microcoulomb allocated 0.2 meter. 0.2 meter apart. In vacuum. Find what? Find Roman 1, the electric field. The electric field at the midpoint. At the midpoint of the line joining 2 charges. 2 charges. That is Roman 1. Roman 2, the force experienced experienced by the negative test charge of magnitude I believe that, ladies and gentlemen, you're enjoying the beauty of advanced physics, and you're enjoying the beauty of advanced electrostatic, and you're enjoying the beauty of electric field or electric fields, and you're enjoying the beauty of solving conceptual questions by using a very simple language. So of the magnitude 1.5 exponent negative 9 Coulomb. Let's see at this point. So that's the question we have on the blackboard. Let us read together. 1, 2, 3. 2 point charges, QA, which is positive 3 microcoulomb, and QB is equal to negative 3 microcoulomb, are located. So are located 0.2 meter apart in vacuum. Okay? Find the electric field at the midpoint of the two line joining, two charges. Roman 2, find the force experienced by the negative test charge of magnitude 1.5 exponent negative 9 placed at this point. So this example 28 is really testing about your understanding on what I've taught. It's not a difficult question, but this is one of the questions which have been asked, and you can find, because this question from paper 2, these are 4 marks, this maybe has 2 marks. So 6 marks are there that you can win or you can harvest. Okay? So let me give you, it means let me give you 1 minute for you to do this. It means you can pause the video and try to do it yourself on a piece of paper before I solve it, so you may get the correction. So please, just do it. Let me give you 1 minute for you to do it. Okay, I just gave you a few minutes to finish to copy, and then you pause the video and you try to solve it yourself. Imagine like you are in advanced certificate examinations paper 2, and then you met with these questions. While I've told you, how will you do it? I believe that you are going to kick it. So, ladies and gentlemen, this is solution for this problem. The first step, we've been given 2 point charges of this magnitude, QA and QB. So the first step, whenever you be given these kinds of the problem, I ask you what to sketch the problem. So to sketch the problems about the information that you've been given. You have 2 point charge, and these point charge are placed in vacuum, and this is the center of this point charge, and this is the center of another point charge, and this is positive. This is QA, and this is positive 3 microcoulomb, and here we have negative 3 microcoulomb. Negative 3 microcoulomb, right? Then the distance between this point charge, is what? Is 0.2 meter. 0.2 meter. That the distance between, so that is QA to QB. So that the distance between them. So the question asks you that find the electric field at the midpoint of the line joining. So midpoint, it's a half of the distance from this point to this point. So suppose that this is the midpoint. Okay, so suppose that this is point C. Okay, so the distance from the center of QB to what? To C is 0.1 meter. Also the distance from what? From the center of QA to point C is 0.1 meter. So what we've been asked? We've been asked just to find out the electric field strength. So this is the second step. The second step, we ask you that find electric field strength. Okay, electric field strength at C due to what? Due to QA. How? You have to recall the formula that electric field strength is equal to K times Q over R squared. So electric field strength at point C due to QA, this is equal to K times Q over R squared. What is K? K is 9 exponent 9 times Q. Q, and this is what? QA. Okay, QA. So QH is what? It is 3 microcoulomb, which is 3 exponent negative 6, divided by distance between QA and C, which is 0.1 meter squared. Alright? So electric field strength at point C due to QA, this is equal to what? So use your scientific calculator. The one that I told you in case you lost it or you don't have it, you can order in TANZANIA online advanced library. So how we do our computation is 0.1, then we square, then we have what? 9 exponent 9 exponent 9, or the response, then multiply by 3 exponent negative. Wait, we have 9 exponent 9, then 3 exponent negative 6, get the response over 0.1 square. The response is what? Is 2.7 exponent what? 2.7 exponent 6 Newton coulomb. So where will be the direction? Remember that whenever the point where we have to find the electric field strength, we have always to let the testing point charge, which is positive 1 microcoulomb. In every case, you have to let that. So this is positive and this is positive. So what will happen to the point charge at C? So it will be repelled by QA. So it will be along what or toward what. So this electric field strength will be toward what? Towards QB. So it will be repelled towards QB. That is the second step, ladies and gentlemen. I believe that you enjoy. We are solving example 28, Roman 1. I'm about to finish this session, so you have to be patient. Soon we'll phase it out. So then we go for the third step. The third step, ladies and gentlemen, we say that let us find electric field at C due to QB. So electric field strength at C due to QB, this is equal to electrostatic constant times QB of what? Over R squared. So this is 9 exponent 9, and this is 3 exponent negative 60 of what? What's R? R it is what? It is 0.1 squared. So electric field strength C of QB, this is equal to what? Okay, so it is to be the same value, 2.7 exponent what? 60 Newton per coulomb. But this is negative and this is positive. So also it will be attracted. So first of all, this is the directions of electric field at C due to QA. And also this one will be attracted. The pointing charge at point C will be attracted by negative 3 microcoulomb. So we have electric field at C due to QB. So it means that these field strengths or field intensity, the electric field strengths are in the same direction. So we go for the first step. The first step, we say that let us find resultant electric field. So to find resultant electric field, this is equal to what? Is equal to electric field at point C due to QA plus electric field at point C due to QB. Because both of the electric field strengths are horizontal and there is no any angle. So the angle between the x-axis and the electric field strength is 0. So if that's the case, you say that the resultant electric field strength at what? At C, or at the midpoint, is equal to what? So it's equal to 2.7 exponent what? Exponent 6 plus 2.7 exponent 6 Newton per coulomb. So with this one, we say that this will make 5.4 exponent 6 Newton per coulomb. So therefore, so electric field strengths, okay, the electric field strengths at the midpoint. At the midpoint is what? Is 5.4 exponent 6 Newton per coulomb. Electric field strength at the midpoint is 5.4 exponent 6 Newton per coulomb. That's the answer of example 28, Roman 1. So copy the question, and hence we want to go for 1-2. The force experienced by the negative test charge of the magnitude 1.5 exponent -9 coulomb placed at this point. So that's the point charge. So there's another. So now this point charge has been replaced with what? So it's been replaced by 1.5 exponent what? -9 coulomb. So what force will be experienced? The force experienced by the negative test charge. So it is negative. So this is negative test charge of the magnitude that one's at that point. So what force will it experience if this is the electric field strength at the midpoint of 40 of QA and QB? So are you ready for that? Are you ready to find the force experience? It's not a difficult question. Okay, so let me leave this part because I will need it in. Okay, anyway. Okay, so if that's the case, we go for the fifth step. This is solution. So the fifth step, we say that what? So recall the formula of relationship between what? Between electric field, quantity of charge, and electrostatic force. So what did we say? Remember that we said electric field strength is equal to electrostatic force over quantity of charge Q. So electric field strength at the midpoint, which we call point C, this is equal to force experienced by the point charge at point C, which is the midpoint, over the negative point charge, which is Q. So the electrostatic force experienced, which will be either, depends, can be just because it's negative till, so it means that this point charge will be repelled by this negative 3 microcoulomb, and this point charge will be attracted by 3 microcoulombs. So the force experienced will be electric field strength at point C multiplied by the quantity charge Q, right? So electrostatic force, this is equal to what? Electric field strength, okay, electric field strength at point C, and this electric field strength at point C, it's what we found is 5.4 exponent what? Exponent 6 Newton per coulomb times what? Negative test charge, which is 1.5 exponent what? Exponent negative 9 coulomb. So coulomb and coulomb cancel. So electrostatic force at the midpoint, okay, electrostatic force, if it's at the midpoint, okay, the electrostatic force, you have tested to use your beautiful scientific calculator. Just press answer. So 2.7 exponent 6, okay, this one, 2.7 exponent 6, answer is 5.4 exponent 6. This one, we have to plus with 1, we have to multiply with 1.5 exponent negative 9. So the force is what? Is 8.1 exponent negative 3. 8.1 exponent negative 3. 5.4 times 1.5. So 8.1 is from this one, but 20 Newton. So ladies and gentlemen, we say that therefore the force, okay, so we say the force experienced at the midpoint, the force experienced by 1.5 exponent 13 exponent negative 9 coulomb is what? So this force experienced is is 8.1 exponent what? Exponent negative 3 Newton at the final response. Wonderful. So right now, ladies and gentlemen, it's a time for me to give you the homework so that you have to go through and you have to try to solve these problems yourself. In case you find that these problems are difficult for you to solve, you may go back, you may watch these videos several times as well as you can until these concepts have been built in your mindset. So let me begin with the one of the conceptual question. Every question that I'm leaving to you, I've already told you its concept in a different style. Homework. So this is homework 14. I believe that you are ready for that. And in sequence of the examples, this is, I want to leave 2 questions today because I know that you've grown up in in your compressions of electric field strengths. So we have questions start like this one, 5 microcoulomb and positive 5 microcoulomb and negative 5 microcoulomb and negative 5 microcoulomb. Okay, negative 5 microcoulomb. Okay, negative 5 microcoulomb. Negative 5 microcoulomb are placed at the corners. So placed at the corners of 40, are placed at the corners of 40 of A, B, C, C and D of square, of 1 meter. Of 1 meter. That is full stop. And then calculate the electric field strength. Calculate the electric field strength. Calculate the electric field strength. Calculate the electric field strength at the center of the square. At the center 40 of the square. That's the question. The square is not given. Positive 5 microcoulomb, positive 5 microcoulomb, negative 5 microcoulomb, and negative 5 microcoulomb are placed at the corners of A, B, C, and D of the square of 1 meter. Calculate the electric field strength at the center of the square. So when you are copying this question, right, it's the concept questions, you have to be careful. Okay, so again, just to have 3 times mean 30, example 30. So with this one, say that refer advanced physics 2 review, or in other words, refer advanced certificate secondary education. I'm just referring this for you to get courage that you can solve even yourself. Now you can solve what? Paper 2. Okay, you can solve the electrostatic questions that has been asked in advanced certificate secondary education examination. So the E8 is 2014, and as I told you, the electrostatic question might be question 4 or question 5 or question 6. So this is question 4. So question 4, it has also 4 parts. Most questions of paper 2 have 4 parts. Means you find question 4A, question 4B, question 4C, question 4D. And you can find also Roman A has its parts, or has what subparts. Okay, has subparts. Okay, so question 4. So question 4A, state Coulomb's law. Okay, so question 4. Okay, so A to B. So question 4A, because I'm giving you, or I want to give you what I have already taught you. State Coulomb's law. State Coulomb's law. Okay. Then Roman 2 gives 3 properties of equipotential surface. I haven't taught you yet. So let us do question 4B. So question 4B, Roman 1, will be asked what is meant. Don't use the review and copy the solution. According to my research, most solutions in these review books are Advanced Physics 1 and Advanced Physics 2 have so many mistakes, but those mistakes are not committed by the author or maybe the person who, or by a teacher who solved this past paper. Possibly these questions, according to my research, they have been done by typists. So be careful on following the solutions of these books. That's why I'm teaching you the concept before you solve the questions, because you can notice a mistake. What is meant by line of force? by line of force. Then we have question 4b, Roman 2. 2 points A and B, with charges of 40 of 1.6 exponent negative 19 coulomb. The negative 1.6 is from negative 19 coulomb, respectively, form ionic dipole. If the year distance of separation is 1.0 exponent negative 10 meter. Calculate the field strength. Calculate the field strength due to the dipole. At a point exponent negative 10. So when you are copying this question, also write concept, because you have to be careful. Even in review, when they've been solving these questions, they made a mistake. Meter to the right of A. The right of what? Of A. If you want to know that I'm not recommending badly, these are the findings, or these are the results that I found when I was going through these review books. Some of the solutions are not right. If you want to realize, solve question 4b, Roman 2, by using the concept that I taught you, or even some other teachers have taught you, and then just to go to review and go and check its solution, and then you'll find that the solution is not correct, because there is kind of the typing errors, and even the instruction of the questions are not followed on the part of the data. So that is my father was never say that Olenjolai is enough. Or let's say that this is the end of session what? This is the end of session 14 of solving conceptual questions of electrical fielding. So in the next session, session 15, I will take you to another concept, but we're still in the electrical fielding as one of the subtopic, but for us we define as topic. So this is the end. I thank God who have created me in his own image, and I thank God who have given me a gift of teaching, and I thank God who have given me a great and even generational idea of teaching the entire nations of Tanzania by using the internet, the power of the internet and digital multimedia devices. And I thank God who have given you opportunity to join me, and I thank God even who will be giving you questions to ask me in the comment section. And I thank God for everything, who have given me strengths and understanding, who have given me knowledge and wisdoms to teach you. So may God bless you, and I would like to invite you in the next session, which will be session 15. Don't miss, for you to get notifications once we publish it, or we add it into our YouTube channel that called Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM. Please make sure that you subscribe for you to get notification. Again, please share these contents to other students across the country of Tanzania, in any regions, including Unguja and Pemba, even in Mafia. If you have a friend who's studying in Forateki, who's studying in Yunga, who's studying in maybe in Kigonsela, so you can share with them that they can enjoy either during the vacations or during the weekends, means Saturday and Sunday, or they can enjoy these contents during the weekdays after the class time. Okay, so it means that you can take advantage of these contents, or during the public holidays, you can take advantage of learning this stuff. Because remember that regulations of many government schools, the students are not allowed to own phones when they are in boarding schools. But it means that in day schools, you have a right to own a mobile phone. So use it effectively and turn your mobile phone or your TV or your computer to be your real-time class of learning this stuff. Again, last but not least, you are receiving these contents free of charge. It's God who paid for you. I mean that the sponsor of these programs is God himself. But God has opened doors and told me that as a teacher of this program and also as the founder of this online advanced secondary school, to open the doors for either a student or a parent or a sponsor or even guardians or a teacher or any volunteer or anybody who is watching this video. If you wanted to see the gospel or to see the good news of advanced physics spreading into the entire nations of Tanzania, you can offer your free willing thanksgivings in order to support the running cost for this program. It's very expensive to make one video. If you remember, I told you that in these programs we expect you to have more than 500 videos for you, or for you and even for your children and children of your children. Okay, so it means that you can offer so this telephone number 0759745331, and believe me that everything you're going to offer, any Thanksgiving that you're going to offer, will be returning back to you by paying the running cost for this program. So there is no any delay, there is no any postponement, there's no any procrastinations of the session. You will find all the contents in your hands at the right time. Okay? But remember that the sponsor of this program is God. It's a very expensive program, I want to tell you, but God, our God, is greater than the expenses for this program. So may God bless you. Keep praying for me. I'm keeping praying for you. And right now, be free from the slavery life, from the stresses of advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics. But ask your questions in the comment section, please. And submit your homework in the comment sections and answer questions which will be asked by other students worldwide in the comment section. And tell us in the comment sections you are enjoying this content from which school, from which region, from which country, from which continent. Tell us in the comment section. Say something in the comment section, please, because that sections I will see, I have a capacity to see, and everybody has a capacity to see. So give us a feedback, because we want to get feedback as long as I'm teaching online. This is Sir and the engineer Olenjolai, just a real sounding and conducting programs and doing the national program for Tanzania by using the curriculums of Tanzania. And I'm ready to teach advanced secondary students who will be pursuing PCM, PCB, PMC, PGM, and ordinary diploma in different colleges, institutions, and different secondary schools, government and private. Receivers also, you can take advantage of learning this content. So may God bless you until we meet again. Stay enjoying the beauty of physics.